Hello everyone, good morning and welcome again to our online science class. How was your week? Did you have a great time? That is absolutely nice. So today is April 26th, it's Sunday, it's a brand new week for our lesson for our online science class. So kindly prepare with you the materials, it's written right over there. If you don't have them, click the pause button. If you have them right now, I think you're ready. I'll have here some ear-boggling question for you, so all you need to do is listen sharply to these questions and guess what are they. Alright, ready? Let's go. This is question number 1. So, where can you hear the sound? Let me see your answer. Definitely it's on the seashore or on the beach. Try to listen to that. That is nice. Well, here's question number 2. Listen carefully. So, where do you think you would hear this sound? Exactly, you would hear the sound on the cashier, but if you answer grocery or mall, well, that's equally the same. So, let's take a look with question number 3 now. Say the name of the place where you can hear this. Well, where can you hear the sound? It sounds real familiar. So, it's on a fireplace, a chimney, or there's a fire, or there's a burning material. Did you get it correctly? Well, it's a pretty tough one. Let's proceed to the 4th question. Here it is. So where do you think was that sound from? If you answered hospital, that is correct. That is the sound of a monitor which identifies the heartbeat of or the respiratory rate of the patient. So here's the last question. Let's see. Just wait for it. So where do you think is that sound from? It's a very familiar place. I bet if you've been there, but not during this COVID pandemic times. It's in the airport. So did you get all 5 marks correctly? Well, if you get all those 5, you are really good with sound. So since we're talking here about sound, what do you think is our topic for today? Have any guess? Well, you get it correctly. It's all about sounds. So we're going to focus here at chapter 11.4. It's sound on a screen. We're going to take a look here. What do you mean there by sound on screen? So kindly open your course book in page 142 to 143. So I have here the objectives for our lesson today. We're going to learn here amplitude and pitch. So we're going to identify here what happens if you change the amplitude of sound and what happens if you change the frequency of the sound. So let's start to see what will happen if we manipulate those 2 dimensions of the sound. So again, I want you to take note of those 2 words, amplitude and frequency. So before anything else, let's review first what is a sound wave. So one example there of an illustration that you can actually see a sound wave is the experiment right over there, and we did it in our Zoom live class. So I have there the what apparatus is that? Exactly, that is a tuning fork, and when I strike it and when I put it in a glass with water, and that thing will happen. So that will tell us that sound wave actually is something that we can see as well as we can hear. So what is a sound wave? Any idea? So definitely a sound wave is just a vibration, just what you can see there with a tuning fork. It is vibrating and it travels through the air, in that case in the water or any medium. It can be a solid, liquid, or gas, or through another material. And the word or the phrase there which says air or through another material, that means on our previous topic we said there that vibration or sound travels in a medium. So definitely sound wave is just made by vibration, which travels in this case through the air. So I want you to take on your mind that vibration is equal to production of a sound wave. So I have here an experiment. I know that you're really familiar with that. We did this one with a ruler, and we have a varying length of that, and we vibrate or we pluck with that. So this is my question: what is the amplitude of a sound? So we actually tackled what is an amplitude and what is a frequency on our previous topic before. So I wanted to take a look with a graph at the top here. So look there, it's a wavelength. So we are manipulating the amplitude. Try to see what will happen. So try to see, if we manipulate the amplitude, what part of the wavelength are we manipulating? Exactly, we are manipulating here the height of the wave. So if you look here in our ruler, I don't have it animated, so I have here a picture just to see you this vibration here on the ruler. So the height here of the vibration of the ruler, up and down, from its resting face or its resting position, we call that difference here as the amplitude. So we call it displacement. Why displacement? Because we created a distance here, we created a height here, we created the difference here between the two positions of the vibration of the ruler and from the resting stage. So we call amplitude as a maximum distance the vibrating object moves from its rest position before it started vibrating. Or just simply, if you take a look here with a graph, when we manipulate the amplitude, we're manipulating here the height of the wave. So take note of that. Amplitude is always equal to the height, or it is the height of a sound wave. So let's apply. How can we identify what is an amplitude in an actual scenario? So I have here 3 scenarios. At this point of time, I want you to predict which of the instruments below will produce the highest amplitude. So I have here A, I have here B, I have here C, and we're going to listen to each of these sound, and I'm going to show you here an oscilloscope. So I want you to copy this one, it's in our Google Classroom, and try different kind of materials and identify the amplitude that is produced. Alright, so I want you to observe at this. So what I did here in the screen is I put the active board over here and our oscilloscope here. So what I did here is I had an online oscilloscope. So if you notice, it's moving right over here. So each movement of here of this line here is equivalent to a certain kind of sound wave. So we are going to identify which of the instruments here will produce the highest amplitude. Alright, so you need to listen carefully and observe at the amplitude right over here. Alright, so again, the amplitude speaks about the height of a sound wave. Are you ready? Okay, let's play this one, and it needs to be real quiet. Alright, so here it is. We are going to play instrument number 1. This time, let's listen to instrument number 2. This time, let's listen to instrument number or letter C. So, which instrument has the highest amplitude? Please type your answer in the comment section below. Do you have the answer in mind? Well, it's pretty obvious. The correct answer for that is definitely letter A. It's the drum. So it has the highest amplitude a while ago. So I want you to think or write the word or words that make you think that A has the highest amplitude. Please write it in the comment section below so that I will know your response. Alright, so can you hear what did you wrote there? So I have here something. So the drum has the highest amplitude because it has the loudest sound. It has more force or more energy, and it creates more vibration. So let's take a look here with the second one. Let's have one more round to identify this time which of the instruments has the lowest amplitude. Alright, I'm gonna play it one more time. I'm gonna play it shortly, and I want you to listen carefully and look again at the sound waves here on our oscilloscope. It's an online oscilloscope, alright? So here's instrument letter A. Alright, I'm gonna play here instrument letter B. And lastly, letter C. So you have seen the sound waves on our online oscilloscope. So which of the three here has the lowest amplitude? Is it A, B, or C? What is your answer? Well, if you answered C, then you were correct. Well, it's really obvious that letter C has the lowest amplitude based on the sound wave. So, what makes you think that the letter C has the lowest amplitude? Kindly write your answer on the comment section below or on your notes right now. So let's compare it with what I have in here. So letter C has, in fact, the softest sound, and you can hear it a while ago. And well, it has less vibration because most probably it has less force and less energy during the time when we vibrated it. And all of these characteristics makes letter C have the lowest amplitude now. So if we are going to take a look in here and we're going to make a sound waves of those two sounds that we have there, we have the drum and the tuning fork. Which of the following sound waves here at the right matches with the instruments at the left? So for the drums, is it A, B, or C? For the tuning fork, is it A, B, or C? Which? I want you to write it on the notes that you are holding on right now, or put it in the comment section so that I will know. Do you have the answer now? Let's check if you got it correctly. So the drum here has a loud sound, and I want you to take a look with the sound waves there on the oscilloscope. And we have here also the tuning fork, and try to see the um, sound waves here on the oscilloscope. So what have you observed? I want you to write it in your notes right now. Well, exactly. What we observe here is for the drum, it tends to have a higher amplitude compared to that of the tuning fork. And a while ago, you can obviously hear that the drum is louder compared to the tuning fork. So we can say here that if a material which has a louder sound, it tends to have a higher amplitude compared to a quiet sound. I'm trying to say with a quiet sound, its amplitude is really low. So you might say here that drum, which has a louder sound, tends to vibrate more compared to that of the tuning fork. Or the force for the drum, for it to vibrate, has more vibrations or more energy or more force compared to that of the tuning fork. So if you look at the amplitude of the sound, how is the amplitude related now to the quality of the sound which is produced? So here is the source of our sound. We have here the instruments. Here is a drum. Here is the tuning fork. Here is how we interpret the sound when, again, sound waves is because of the vibration, and again it travels through a medium, and that is the air. So the small blue circles here are the molecules of the air, and try to see what happens versus this one for the tuning fork. So if you look here, there's a concentration, there's a big push and pull, there's a big vibration here, a more forceful vibration here for the loud sound, and that is for the drum, compared to that of the soft and quiet sound. And try to look at the amplitude. The louder sound tends to have a higher amplitude than that of the lower amplitude. Therefore, we can say here that the louder the sound is, the higher is its amplitude. The softer or the more quiet a sound is, the lower is its amplitude. So when we talk here about amplitude, what dimension of the sound are we trying to distinguish here? Exactly, we are trying to distinguish here volume of the sound. So amplitude, or the volume of the sound, depends upon the amplitude of the sound waves from the sound source. Alright? Well, that is so much for the amplitude of the sound. This time, we're going to take a look with the frequency of the sound. Well, just to review, what is the frequency of the sound? I have here two sound sources. I have sound source A and have sound source B. I want you to look at it closely. Just do not focus at the air molecules first here at the top. Focus on the line graph that we have here, which is produced by our oscilloscope. I want you to take a look with the difference between the sound waves from source A and source B. What have you observed? So you might observe that sound waves from source B is closer than that of the source A. It's really obvious here. So if you look here at the air molecules over here, well, it's really closer than that of the source A here. And if you look also with the source A, it tends to have a wider sound waves or wavelengths compared to that of the A. So therefore that whenever we say or we talk about frequency here, we talk here about how closer the waves are with each other, or how frequent. That's why it's called frequency. How frequent does the vibration occurs here for every second, because each wavelength here is equivalent to one complete vibration. So let's try to see and let's try to listen here to sample sounds, and let's identify which sounds here tends to have a higher frequency compared to the others. Alright, so let's take a look again one more time with our oscilloscope. So this time we're going to identify here which length of the ruler will give the highest frequency of the sound. So we are going to give variations here with the length, and that is our variable that we were going to change here. And we're going to plot it, and we're going to identify which of the lengths here will give the highest frequency of the sound. So I have here the ruler, and I have here the oscilloscope, which produces our sounds. And I want you to listen carefully, and I want you to take a look with the frequency of the sound. Again, I'm going to show you here one more time the frequency. I want you to look here whether the wavelengths are spread apart or the wavelengths are really close with each other. Alright? So I want you to take a look with the oscilloscope that I have in here. So let's put it in volume up and let's take a look first. First is we have the 3 inches. Alright, so I want you to take a look with it again the second time. I'm gonna point here again which of the length are we in now, so you have to do multitasking, look at the length in here and try to look at the sound waves. Alright, I'm gonna do it one more time. Listen carefully. Alright, so it's really obvious in there. So, which of the following length of the ruler will give the highest frequency of the sound? Please write your answer on the comment section below and we'll see if it's right or you got it correctly. Alright? So what's your answer now? So the correct answer here is actually letter A. It's the 3 inches. So it's the shortest one, which will give the highest frequency of the sound. Well, this time, let's observe now and answer the question, which of the following length of the ruler will give the lowest frequency of the sound? Again, we're talking here about the lowest frequency. Is it A, B, C, or D? And, well, for your curiosity, let's try to observe, and I'm gonna let you listen to it one more time. Alright, listen carefully. Here it is. So, which length of the ruler there give the lowest frequency of the sound? Is it A, B, C, or D? What is your answer? Well, if you answered D, you are correct. It's the 8 inches. So again, to recall, the one with the highest frequency of the sound is A, and that is the shortest one. And the one with the lowest frequency of the sound is letter D. So I want you to take a look here. This one is how we interpret the sound waves a while ago for the 8 inches. So I'm gonna show you again. What about for the 3 inches? This is for the 3 inches. So try to look at the frequency, at the wavelength. So this one is more compressed, and you can see that for each second. Well, let's see. One picture of this says that the number of vibrations for every second. You have how many vibrations in here? Well, that talks about the number of wavelengths that we have in here. So I have 1, 2, 3, 4, and 5. But compared to that of the longer one, it's the 8 inches. I only have here 2, right? So, which means that the shorter is the ruler, the more frequency, or the higher is the frequency that is produced, and the lower or the longer is the length of the ruler, the shorter or the lesser or the lower is its frequency. So here's my question. Write the word or words that help you think that the 3 inches has the highest frequency. What do you think? So let's compare your answer with mine. Well, if you observe there, because it vibrates more compared to the other lengths, I'm gonna play this one again and let's observe. We'll look at the vibration. That one is for the 4 inches. This one is for the 6 inches. And this one is for the longest one. Well, if you see, the shorter one vibrates more compared to the other lengths, and that is the reason why it tends to have a more or higher frequency compared to the longer length of the ruler. And if you listen to it, the sound is really sharper compared to the other length. I want you to listen to it one more time and pay attention. That is the sound of the shorter. This is the 4 to 6 inches. The next. And this is the longest one. So if you notice which one has a sharper sound, that is for the, exactly, the sharper sound goes to the 3 inches. So we just had identified that the shorter the length is, the more vibration it creates, and more vibration means higher frequency for the sound, and the longer is the length of a certain object and it vibrates, it tends to have a lower frequency, and it tends, because that's the reason because of that, the reason why is because it tends to vibrate lesser compared to the shorter one. So this time, let us listen again to the quality of the sound produced by each length of the ruler. We have here again the 3 inches, the 4 inches, the 6 inches, and the longest one, which is the 8 inches. And I want you to really pay attention to the length of the ruler and the frequency, as well as the quality of sound. And we're going to relate here, is there any relationship between the length of the ruler with the frequency and the quality of sound? Alright, are you ready? Well, let's go. Alright, so we're gonna play it one more time, and I want you to observe the quality of the sound with each length and the sound waves that's produced right over here. Alright? So, one more time. So, what was your observation? Was there any relationship? So, let's take a look here. So, the length here are the 3 inches, the 4 inches, the 6 inches, and the 8 inches. So, let's identify here what frequencies do we have. So, I have here, look at this one. Which frequency would this one belong? Is it for the 3, 4, 6, or 8? Exactly, that is for the 3 inches. Good job. How about this one? Look at this. Well, it's more, if you can compare it with the 3 inches, this one is lesser, has a lesser frequency compared to 3 inches, so most probably this belongs to the 4 inches. And let's take a look here. This one is really the one with the least frequency, so most probably it's from the 6 inches. And well, I put it here, 6 and 8 inches are the same because the sound for me are just pretty much the same. Alright, so let's take a look with the quality of sound in here. So, which here has the highest frequency? You bet it right, it's with the 3 inches. The one with the higher pitch. Exactly, that belongs to the 4 inches. How about with the lowest pitch? Before we do the lowest pitch, I have here a lower pitch. Well, the lowest pitch, you are right, it belongs to the 8 inches. I'm going to put here 8 inches, and the lower pitch belongs to the 6. I want you to look at the trend there. So look at the length, look at the frequency, and look at the quality of sound. So what can you conclude based on that? Exactly. The lesser is the length, the more frequent it is, the higher is the frequency, or the more frequent is the wavelength happens or occurs for every second. So what happens to quality of sound is the pitch tends to increase. However, if I increase the length of the ruler, the vibration is lesser. So what happens is it tends to have a lower frequency. And what also happens to quality of sound? Lower frequency results to production of lower pitch, and higher frequency tends to result on the production of a higher pitch. That is really a great job identifying if there's any relationship between these 3 variables we have. So here's what we have So far, we have sound based on amplitude and we have sound based on frequency. So I have here the sound waves for the amplitude. If the amplitude is really high, well, it's a loud sound. And if the amplitude is not that high, just compare just what we have here in the picture, it is a quiet sound. And if it's really flat, just like that one, well, it is silence or the absence of sound. So no vibration, no wavelength that is produced. However, we have two dimensions where we have two types of sound based on frequency. So if it's really here, more vibrations for every second, so it tends to have more a higher frequency, so therefore it has a higher pitch. And with this picture right over here, it tends to have a lesser wavelength, so lower frequency here tends to have a low pitch. Alright, so I want you to take note of this 5 wavelength or sound waves that I am showing to you here and identify what kind of sound is producing it. So again, I want you to differentiate amplitude and frequency. For amplitude, we're talking there about loudness or softness of the sound. For the frequency, we are talking always of the pitch of the sound. So if you want to play and review or revise again this video, I want you to put it on rewind and take a look and take a listen again with the sound produced here. However, if you're ready, well, let's test how much you've learned so far. So what I have here are the scenarios of the sound, or I'm gonna let you listen to the actual sound, and I want you to identify which sound waves best describes it. Alright, so are you ready? If you're ready, let's go. So what we're going to do is to analyze the situations and choose which sound wave is produced. Choose from the sound waves above, right? Only the letter, 1 mark each. Are you ready? Okay, let's take a look with question number 1. Listen carefully to this. So is it A, B, C, D, or E? What's your answer? If you answer A, you are definitely correct. Let's take a look with number 2. This one is in the picture, and what can you see in the picture? So identify what sound waves would you expect if you are on that place. What's your answer? Well, let's check. The correct answer here is definitely letter B. Let's take a look and listen with question number 3. Alright, so what kind of sound wave would you expect for this? Let's check your answer. It's definitely letter C. And how about for number 4? Let's see. If you were in that place, it can be an office or a bank or an office, most probably. So what kind of sound waves would you expect on that? Let's check your answer. It's definitely letter D. It's a quiet sound. And the last but not the least, let's take a look with the sound on number 5. Well, it's on a street. It's in a traffic jam. So what sound waves would you expect on that? Let's see if you get it correctly. The answer is letter E. How much marks did you get? Did you get it all 5? If you get it all 5, that is awesome. That is excellent. However, if you need more time to revise, kindly rewind this video again and look at and observe, revise at it in any of your most convenient time. So if you don't have any other question, you can let me know of your mark and let me know of your thoughts about this lesson. If you have question or clarification, kindly send me a message on this. And if you're doing the Zoom live meeting, you can leave at this time, and see you on Tuesday. Worksheet will be posted on the scheduled time, and I'm going to announce that. Alright? So, hope that you learned something today. That would be all. Goodbye, everyone.